In this video, we are going to learn about thermochemistry, subtopic concept of enthalpy. Before we start off, let's find out the meaning of thermochemistry. It is a study of heat change in chemical reactions. Let's look at a simple example. Shown here is a cup of hot water and an ice cream. They are known as a system. The air around these two systems is called the surrounding. Between the system and the surrounding, there will be exchange of heat. Now, how does the heat change occur? Heat will either be absorbed or released to and from the system and the surrounding. Please bear in mind that heat only flows from a hot body to a cold body. Hence, if we leave a cup of hot water on a table at normal temperature, the heat in hot water will be released to the surrounding and the water will cool down. While, if we leave ice cream on a hot day, ice cream will absorb heat from the surrounding, causing the ice cream to melt. This shows that the heat change has occurred in these systems. In thermochemistry, there are three types of systems. The first one is open system. Open system is a system that can exchange mass and energy with its surroundings. An example of open system is boiling water without a lid. Heat energy changes between the system and the surrounding, and the steam produced from boiling will escape freely to the surrounding, causing the mass to change too. The second one is closed system. Closed system is a system that allows the exchange of only energy with its surroundings. An example of closed system is a pressure cooker. While cooking, only heat energy will exchange between the system and the surrounding. The steam produced from the cooking is not allowed to escape from the cooker, so there will be no change in mass. The third one is an isolated system. Isolated system is a system that does not allow the exchange of either mass or energy with its surroundings. An example of isolated system is thermoflask. This system is completely sealed. If you put hot drink in a thermoflask, the hot drink will stay hot in it. No change in heat energy or mass at all. In learning about heat change in thermochemistry, there are two types of chemical reactions involved. It is endothermic reaction and also exothermic reaction. We'll go through them one by one. Endothermic reaction is a process that absorbs energy from the surrounding to the system. This process results in an increase in the enthalpy of a system. If we refer this example from before, ice cream will absorb heat from the surrounding and it will melt. In a way, this is an endothermic reaction. Generally, this is how the energy profile diagram of an endothermic reaction looks like. The x-axis shows the reaction progress, while the y-axis shows the value of energy or enthalpy of a system throughout a reaction. As you can see here, the enthalpy of the reactant is at the bottom of the scale, while the enthalpy of the product has higher value. This shows that the heat is absorbed from the surrounding, causing the enthalpy to increase. Now, let's look at exothermic reaction. Exothermic reaction is a process that releases energy from the system to surrounding. This process results in a decrease in the enthalpy of a system. If we refer this example from before, hot water will release heat to the surroundings so that it can cool down. In a way, this is an exothermic reaction. If we refer the energy profile diagram of an exothermic reaction, the enthalpy of the reactant is higher compared to the enthalpy of the product. This shows that the heat is released to the surrounding, causing the enthalpy to decrease. Hence, the enthalpy of reactant is larger than the enthalpy of the product. At this rate, you might be wondering what is enthalpy that I've been mentioning in the previous slide. Now, here are some important terms that you must know in learning thermochemistry. The first one is enthalpy, or the symbol H. It is a measure of the heat content of a substance at constant pressure. Basically, enthalpy tells you how much heat does a system have. Next is the enthalpy change, or the symbol is delta H. It is the difference between the enthalpies of the products and the enthalpies of the reactants in a reaction. This is the formula in calculating the enthalpy change. Enthalpy of products minus enthalpy of reactants. And lastly is standard enthalpy, or delta H naught. It is enthalpy change measured at standard conditions. You have to know what are the standard conditions. The first one, if your substance is a gas, it has to be at 1 atm pressure and it behaves ideally. Next one, if a substance is an aqueous solution, it needs to have 1 molar concentration. Lastly, if a substance is a pure substance, where it is an element or a compound, it has to be in the most stable form, which is at 1 atm pressure and at 25 degrees Celsius temperature. You have to get yourself familiar with these terms as you'll use them a lot along the way. Another important term that you must know is the thermochemical equations. It is chemical equations that show the enthalpy changes, delta H. Basically, is the usual chemical equation that you always write down, but with an additional enthalpy value at the end of the equation. In thermochemical equations, these two aspects are very important. The first one is the sign of an enthalpy value. A positive enthalpy indicates that the reaction is endothermic, while a negative value of enthalpy indicates that the reaction is exothermic. Another important aspect is the magnitude of an enthalpy value, since it shows the stoichiometrical relationship of a thermochemical equation. Let's look at this equation. This equation shows that if 2 mole of hydrogen is burned in 1 mole of oxygen, an amount of 572 kilojoule of heat energy is released. Now, what do I have to do if I want to find out the value of enthalpy for the combustion of 1 mole of hydrogen gas? What I have to do is, I have to divide the whole equation by 2, including the value of the enthalpy. Hence, the combustion of 1 mole of hydrogen gas releases 286 kilojoule per mole. Please note here, kilojoule per mole means that the value of enthalpy is for 1 mole of compound only. There is a lot of chemical reactions involving change in heat energy in its systems. In order to study their heat or enthalpy change, you have to know the definition of an enthalpy for each reaction. Here are some important types of enthalpy changes that you are going to learn. They are enthalpy of formation, enthalpy of combustion, enthalpy of atomization, enthalpy of neutralization, enthalpy of hydration, and lastly, enthalpy of solution or dissolution. Enthalpy of formation is the heat change when 1 mole of a compound is formed from its elements in their most stable state at standard conditions, which are pressure of 1 atm and temperature of 298 Kelvin or 25 degrees Celsius. Formation of a compound must occur in standard conditions. Hence, enthalpy of formation and standard enthalpy of formation share the same definition. There are a few things that you have to pay attention here. In the definition, it states that in an enthalpy of formation, the heat is changed. That means the heat can either be absorbed or released. Another thing that you have to pay attention here is it says that 1 mole of a compound is formed. That means in enthalpy of formation, the equation that you have to produce is only for 1 mole of a compound. These are the examples of enthalpy of formation of a compound. Let's look at the first equation. In order to produce 1 mole of water, this reaction releases an amount of 241.8 kilojoule per mole heat. And in the formation of 1 mole of water, it has to be formed from hydrogen gas and also oxygen gas. Why? Because these two elements are present in water molecule. Please note that the unit for the enthalpy here, kilojoule per mole, is only for 1 mole of compound. Let's look at the second equation here. In order to produce 1 mole of carbon dioxide, it requires the reaction of carbon and also oxygen, which is the elements in their most stable state. And the formation of 1 mole of carbon dioxide releases an amount of 393.5 kilojoule per mole of heat. Most enthalpy of formation will have a value that is smaller than 0. That means most of the enthalpy of formation value has a negative value. Another thing that you have to know is a compound is more stable than its component elements. For example, 1 mole of water molecule is more stable compared to hydrogen gas and also oxygen gas. If you noticed, I've only talked about the enthalpy of formation of a compound, but what about the enthalpy of formation of an element, since compound needs to be produced from its elements? This is because the standard enthalpy of formation of any element in its most stable state form is 0 because elements are formed from their respective atoms or elements. So, there is no heat absorbed or released in their formation. Here are some examples of enthalpy of formation of these elements. Enthalpy of formation of oxygen gas, chlorine gas, hydrogen gas, and carbon are all 0. Enthalpy of combustion is the heat released when 1 mole of a substance completely combusted in oxygen gas. The words that you have to pay attention here is heat released. That means all value for enthalpy of combustion is negative. And the other word that you have to pay attention is 1 mole of substance. The enthalpy of combustion is only for 1 mole of compound. If there is more than 1 mole or less than 1 mole of compound, then you have to do something with the value of the enthalpy. If we look at the example here, the combustion of 1 mole of carbon produces 393.5 kilojoule per mole heat. Please bear in mind that these values are only for 1 mole of substance burned in oxygen. Next is enthalpy of atomization. It is the heat absorbed when 1 mole of gaseous atoms is formed from its element. The key word here is heat absorbed. It means that the value of enthalpy of formation will always be a positive value. Then, the next keyword is 1 mole of gaseous atom is formed from its element. For your information, an element can be in any state. It can be in molecule state. It can be a solid. It can be a gas, etc. So, it doesn't matter what is the state of the element, but it has to be formed into 1 mole of gaseous atom in order for you to get the enthalpy of atomization. Let's see an example. In this case, sodium as an element is in solid state. In order to get the value of enthalpy of atomization, you have to convert the solid sodium into a gaseous sodium, because this is the gaseous atom as stated in the definition. And the enthalpy of atomization for this reaction is positive 109 kilojoule per mole. Why does it have a positive value? Because it is stated in the definition that heat is absorbed. Another example is the atomization of chlorine gas. For your information, chlorine as an element exists as a gas molecule. In order for us to atomize this chlorine gas, we have to convert it into just Cl, indicating that it is an atom in gaseous state. Then, you have to balance the equation. Remember, you cannot balance the equation by adding 2 mole of Cl here because in the definition it is stated that 1 mole of gaseous atom is formed from its element. So, what you can do is you can balance the equation by adding half Cl2 at the front of the equation, which will produce only 1 mole of chlorine gas atom. And the value of enthalpy for this atomization process is positive 121 kilojoule per mole. Bear in mind that the positive sign represents that the heat is absorbed during the reaction, and the unit kilojoule per mole represent that 1 mole of gaseous atom is produced in the enthalpy of atomization. Then, enthalpy of neutralization. It is the heat released when 1 mole of water is formed when acid reacts with base. Heat released means that the value of enthalpy of neutralization will always be a negative value. Let's look at an example. In this reaction, hydrochloric acid reacts with sodium hydroxide base, producing sodium chloride salt and also 1 mole of water. The amount of heat released in producing 1 mole of water in this case is 56.2 kilojoule per mole heat. Please bear in mind that this is the value of enthalpy of neutralization that is produced when 1 mole of water is formed from the reaction between an acid and also a base. The next example is the reaction between nitric acid and barium hydroxide, producing barium nitrate and water. In order for you to produce 1 mole of water, the value of enthalpy of neutralization is negative 58.2 kilojoule per mole. You have to be careful when balancing the equation. The other way for you to balance this equation is this way. 2 moles of nitric acid plus 1 mole of barium hydroxide producing 1 mole of barium nitrate and 2 mole of water. In this case, the value of enthalpy will not be the same since the amount of water here is 2 mole of water. So the value of enthalpy will be different. You have to multiply the value of enthalpy for 1 mole of water by 2. So you have to be careful when balancing the equation according to the definition. When the definition says that the enthalpy of neutralization is heat released when 1 mole of water is formed when acid reacts with base, you have to balance the equation in a way that you will get 1 mole of water at the end of the reaction. Enthalpy of hydration is the heat released when 1 mole of gaseous ion is hydrated in aqueous solution. So, when the definition says that heat released, it means that the value of enthalpy of hydration will always be a negative value. And the next word is 1 mole of gaseous ion is hydrated in aqueous solution. That means in the process of hydration, a gaseous ion will be converted into an aqueous ion. Let's look at this example. In this example, sodium ion, gaseous sodium ion is converted into aqueous sodium ion, and the process that occurs here is called hydration. And the heat released from this process is called the enthalpy of hydration. And in this hydration process, the value of enthalpy of hydration is negative 406 kilojoule per mole, which indicates that in this process, an amount of 406 kilojoule of heat is released. Please bear in mind that the unit kilojoule per mole represents that 1 mole of gaseous ion is hydrated in aqueous solution. Next is the enthalpy of solution. Enthalpy of solution is the heat change when 1 mole of substance dissolves in solvent, usually water, to form an infinite dilute solution. Please note here, it's stated there in the definition that heat is change. That means heat can either be absorbed or released, which also means that the value of enthalpy can either be positive or negative. If you recall from your previous knowledge, when a substance is dissolved in water, it will dissociate to form aqueous ion. This is an example. Solid potassium chloride will dissociate and form aqueous potassium ion and chloride ion, and the enthalpy of this process is called the enthalpy of solution. In this process, an amount of 690 kJ per mole of heat has been absorbed. Why do I say that it is absorbed? The value of enthalpy here is positive. That means that the heat is absorbed in this process. And that's the end of this video. Please get yourself familiar with these terms as you will use them a lot in subtopic 2.3 and 2.4. Thank you.